wouldn't say it's the easiest, but I like it. There is one fun, but I'm not going to go over it.
Okay.
Okay, so 7.6 is now integrating logs. So there's only 2 rules on this one, so that's kind of nice. Okay, so this is on your little sheet that you have. This is number 13 and number 14, right? Okay, number 13 is very straight up. The natural log of one, or excuse me, the integral of 1 over x is the natural log of the absolute value of x. Okay, and then number 14 is in terms of u. So number 14 is a U-substitution idea. It's a piece of cake, Matt. Don't be scared yet. Okay, so let's do this. Number 1. So the first thing that I noticed off of number 1, Jarrett, want to put your phone down? Thanks. Is that there's a -3 that's on the top. Okay, so the first thing I'm going to do is I'm going to pull this away and just rewrite this as -3 times the integral of 1 over x dx. And then this little piece now is exactly rule number 13. Okay, so what is the integral of 1 over x? The natural log, yeah. So it's just -3 times the natural log of the absolute value of x. Don't forget your plus c, yeah. Okay. Number 2. That one was so easy. So let's do a harder one. Number 2. Which rule are we going to use? Number 13, number 14? Definitely number 14, right? Okay, it's definitely more complicated than 1 over x. Okay, so what I'm going to do, I'm going to start by identifying what my u is. Okay, so the u simply comes from the denominator. So in this case, my u is p squared plus 1. Okay, so I'm going to start by deriving that. So what is the derivative of p squared plus 1? 2p. So now what I'm looking at is I'm going back to my little integral and comparing the two. Is p the same as 2p? What's the difference?
2.
There's a 2. Okay, so what I'm going to do is I'm just going to put a 2, but if I put a 2 up on the top, that's technically multiplying the equation by 2. So I can't just multiply by 2, I have to undo it. So how do I undo multiplying by 2? Divide by 2. So I'm going to do the dividing by 2 out in the front. And now my integral is set up perfectly for question number, or for rule number 14. I have literally a du over a u. So what is my integral? P squared plus 1, perfect. Okay, so you just plug it right in and you're all done. How'd it go? Do there? Good? That makes sense? No sense?
I got it.
Okay, so do you see actually how the top is my u derivative? See how if I like replace this, this would be the u prime and the bottom would just be u. So see how this is number 14? It's like literally written the same. So all I do is I just integrate it and it becomes a natural log of the absolute value of u, which my u piece is the 1/2 part. Okay, so do you understand how the derivative of p squared plus 1 is 2p? Okay, so if I compare that to the original, there's only a p. So I have to make it become 2p, so I had to multiply by 2, and I had to undo it, right, the top and bottom, yes. There we go. Okay, so let's do number 3. Which rule am I going to do for number 3? 14, so I'm going to identify my u. What's my u? T cubed minus t squared. So what's the derivative of u? 3t squared minus 2t. And now I'm going to compare it and look at the top. And okay, so basically what I can do, yeah, you're close. So what I can do is if I pull the 3 away, like I pull out a greatest common factor of 3 off of the top, so watch how I write this. 3 times, this becomes 3t minus 2, whoops, squared, minus 2t over the bottom piece. Okay, and now since I have that 3 that's in front, I can pull it off just like what I did for question number 1. That's a constant. I can pull it in front of the integral. Okay, and now it's literally my du over my u. Okay, so if I integrate that, what does it become? Mm-hmm. I absolutely hate when they use t's and absolute values and l's. I don't know, but I had to like get in the habit of curling my l's so they look like l's rather than absolute values. It's hard to change. All right, we good with that one?
That was good.
Okay, number 4. Now this one is interesting. Oh, my plus c, thank you. I would have got -1/2 for that. Okay, if I look at number 4 and I go, oh, okay, which rule can I use? You'd be thinking, okay, probably 14, but if you look at the top, is it the derivative of the bottom?
No.
Not even close. It's got too many exponents. Okay, so when we have something that is too big, what we're going to do is we are going to divide it by using long division. You guys remember how to use long division?
Is that where you do like exponent? I mean the constant. Oh wait, no, that's synthetic division.
No, you can't use synthetic, not in this case.
No.
Let's use long. This isn't hard. Gotta do long, yep. Okay, so the bottom goes out in the front, and then the top piece goes inside the little box. Okay, so you start by looking at the first term. Okay, so what do you have to multiply x squared by to make it x squared?
1.
1. So 1 goes on the top, and then you multiply it through. So what's 1 times x squared? And what's 1 times 2? 2. So make sure when you write it that you line up your terms vertically.
Wait, why did you, yeah.
Because I'm multiplying it through this.
Because you can't do, because the original one doesn't have like an x.
Mhm.
X squared.
Yeah, do you see what I'm multiplying it through? So the 1, this 1 is getting multiplied by this.
Okay.
So 1 times x squared is x squared, and 1 times 2 is 2.
Oh.
And I'm just lining them up.
Why do you put your one all the way?
On the top, it doesn't really matter where you put the 1 at, just on the top. As long as you line up everything else. Okay, so now do you guys remember, do I subtract or do I add?
Subtract.
I don't know why I said that first, but there you go. So you subtract. Ashley, are you ready? Okay, so we subtract our x squared, just go away. That should happen every time. How many x's do I have?
-4.
-4, because it's -4 minus 0. How many constants do I have? 0. 2 minus 2. So what is the -4x? That's the remainder. So we write the remainder as minus 4x over the divisor piece. Well, I just wrote it as a minus. So usually it would be plus. I just wrote minus instead. Okay, so that means that 1 minus 4x over x squared plus 2 is exactly equivalent to the piece that I had inside the integral. Okay, so I'm going to replace this. This is 1 minus 4x over x squared plus 2. Whoops, 4x. Okay, so you don't have to write this next step. It's up to you. Since you have 2 terms, you're just going to integrate each term individually. So you could write it as the integral of 1 minus the integral of the 4x over x squared plus 2.
When you do long division, what you get out of the division is
Equivalent.
oh.
Yes. Yep. It's like saying if I have 2 fourths and I divide that, or I shouldn't say 2 fourths, like 4 halves. 4 halves is equivalent to 2 because I divided it. Okay, so let's integrate this. What is the integral of 1? X. Yeah, x. Okay. Now on the second term, which rule am I going to use? So I've got this fraction going on. 14. Okay, so I'm going to identify my u. My u, whoops, let me use a green. U is x squared plus 2. So what's the derivative of x squared plus 2? 2x, whoops. 2x. So now if I compare that to the top, is it the same? How do I make it look the same? Pull the 2 out. So is it okay if I pull the 2 out and put it in front of the integral instead of keeping it inside? Or is that too confusing?
You can do that.
Does everybody follow that?
Can you just multiply 2 to the derivative?
What do you mean by the derivative? No, you don't want to touch the green stuff.
What?
You can't touch like the green stuff over there.
Okay.
Okay, so now my integral is set up perfectly. I have a du over a u, so I'm going to integrate it. So what's the integral of that piece? Oops, I wrote ln. Okay, good. Natural log. Okay, that one, how's that one go? Anybody got questions on that? Okay, so the next part here is basically doing U-substitution, which I did before, but we're going to actually rewrite the function in terms of U's and actually do the actual substitution part. Okay, so for example 5, are we ready over there?
Yeah.
Okay, how would I do this first question? So if I rewrote this, this is the same as the natural log of x times 1 over x, right? Okay, so what I know is that I'm going to have to pick a u and then derive it. So which one is my u and which one is the derivative of u? The u is your natural log. Whoops, I keep writing ln. The derivative, but you have to derive it. No, we're not doing, yeah, this is like straight up substitution. I'll show you what I mean. So, okay, I'll show you. I'll keep going. So what is the derivative of the natural log? 1 over x dx.
Why is
Okay, so I'm going to show you why I wrote that.
Why is that? Why is the natural log the u?
Because its derivative is 1 over x. You can. Because they're derivatives of each other, right? So yeah, so you can do this one of two ways. Okay, so Ashley noticed that I didn't write a u derivative term. I wrote du literally. Okay, so there's a reason why I did that. Okay, when you're doing u substitution, the idea is that you're going to rewrite the integral in terms of the u and replace all of the x's with u's. Okay, so du is equivalent to 1 over x dx. So do you see how these two are the same? And I can replace the 1 over x dx with a du. You see that? Okay, and then I can also replace, sorry about this little, my natural log of x with a u. Okay, so this becomes the integral of u du. Well, I'm not done yet, but that was the substitution part.
So confusing because in the other one,
Right. because we used that rule number 14 and we had the u derivative over it. Okay, so now what is the integral of u? What's the integral? So 1/2 u squared? Oh, you just add, remember, just basic integration. You just add 1 to the exponent and divide by that number. Good job, man. Okay, I just did a basic integral.
And then you just replace your terms.
And then you just plug it back in. So I'm going to replace my u now with the natural log of x. No, because I'm integrating it. It now becomes a notation.
So yeah.
Okay, and make sure that you put the natural log in parentheses because the natural log is squared, not just the x. That's important.
Substituting in the first place.
Instead of just using a rule number 14. You could have just used a rule number 14.
Yeah, that's
But we're, I guess, practicing U-substitution. Maybe that's why it's so confusing. Okay, let's try number 6 with the U-substitution. Are you ready? Okay, so first thing that I want to do is identify what my u is. Okay, so remember the u usually is the piece that's in parentheses. I'm going to do that on the next step.
So you kind of like split it apart, 1/x times 1/x.
You can split it apart if that makes you feel better. Okay, yep, got it. Let's do that. 1/x. Can I say that this is 2 minus the natural logs of x to the -3 then? Is everybody okay with that? Okay, so then what's my u? Okay, the u is usually the piece that's in the parentheses. That's usually very easy to identify. On number 5 it was hard because we only had 2 terms. Okay, so 2 minus the natural log of x. Okay, we're going to do a derivative. No. Okay, so what's the derivative of 2 minus the natural log of x? Good, -1/x. And what do I have to include? dx. Okay, so now do you see how this part, let me use blue, this part, the du, is equivalent to this part almost? Do you see that? How is it almost the same? I need a negative. Okay, so what I can do is I can put a negative in there, but if I multiply by a negative, I also have to like undo it and do another one. I need a negative. So now they're exactly the same. So now this piece right here is my du.
Put in the negative front, -1/x.
Okay, wait, what?
You put the negative what next?
That's the point.
Yeah, they have to be the same.
Yeah, they are.
It didn't have it originally. I had to add it.
You have to, so that way it's still the original.
Okay, so what's my substitution part? U to the -3 du. What? Are we still stuck on the negative? Okay, so the original did not have a negative, right? You get that the original did not have a negative?
Pull the negative out, shouldn't the dx be negative?
Shouldn't the dx be negative? No, I'm just putting a negative inside next to the 1/x. But if I put a negative, I have to have 2 negatives because 2 negatives make a positive. It has to be, I can't change the value of the function, the integral. I can't just throw an x on there for no, and not undo it. Okay, so what is the integral of u to the -3rd? Remember, we're adding 1 and dividing by it.
1/4.
Add 1.
U over negative.
Negative 2, yeah. Negative 2, u to the negative 2. Okay, so now is it okay if I substitute it back in? And I have a negative negative? Yep. And I went ahead and put it into the denominator because we had a negative. You don't have to do that if you're doing a free response, but I always like to simplify it best I can.
Wait, what did you plug into what?
On this last step, so I plugged my u back in right here.
Okay.
Uh-huh.
still kind of confused about
Okay.
kind of there.
Well, okay, the du is, the idea is that I'm deriving it, and think of it like implicitly. Okay, so I'm deriving both sides. So if I derive, so I have u equals 2 minus the natural log of x, and I'm deriving that whole piece. So if I have a u and I derive the u, that's 1 du.
All right. Got you.
And then I do the other side. Yep. Okay. This is the example that's really gnarly. I'm not going to do number 7 with you. Okay, and I'm going to wait till we get to that problem and we'll do it together. This one requires long division and U-substitution, which we'll save for Monday when you guys are more awake.
It's like 11, 12.
I think there's only one problem that has it. I think it's only number 14. I think I circled it. All right, so your assignment is 1 through 14. Let me double check. 1 through 14.
You can't do one.
Yeah, number 14 is the one that's pretty gnarly. So I'll do that with you, unless you take a stab at it, which I recommend trying at least. 14 is the one that requires that long division and U substitution.
They're adding numbers.
Yeah, what do you do when it adds